Thank you all for coming. My name's James Williams, and this is Demystifying Constraint Layout. And this is a talk mainly for Android developers. So if you're not Android, you might not get as much from this talk. Just to start out, I work at Udacity. We are a company that makes programming courses on the internet. And kind of one of our more popular products is our Android Nano degree that we made in development with Google. And we also have nano degrees for different areas like data analysis, machine learning, all that types of stuff. And kind of one of the awesome things about the partnership with Google is we just welcomed about 20,000 students from the Europe, Middle East, and Asia area to take our nano degree programs to learn to become Android developers. And if you're interested in the Android nano degree, you can check out that link there. But let's really get started. This talk is also related to material design. I did a material design course at Udacity. It's all available free, so you can go to that link and check it out. So what we're going to talk about today is, of course, constraint layout. But before I get to constraint layout, I want to talk about why constraint layout is sort of needed, why it's important to think about how things are rendered when you are making a design on Android. Excuse me. So the first thing is, let's talk about the Android view lifecycle. So first there's a measure pass, and then a layout pass, and then you draw the things. So when you're measuring a view, and I don't see my notes here, but that's fine. I can ad lib it. So when you're measuring a view, that's when Android is figuring out where things are going to, how big things are going to be. And it does that with an onMeasure call. And it takes a width measure spec and a height measure spec. And basically each view has this function, and it describes the request from the view to Android of how big things are going to be. And water. Sorry? So the measure spec stores two pieces of data, a mode and a size. Now, for that specific mode, there are a couple of different values. The first value is exactly. This is the element saying it knows exactly how many dips it wants to be. That's density and independent pixels. There's another one for at most, which it's saying it wants to be as big as it can be, but at most this size. And then the third one is unspecified. That happens when you have things like wrap content, because it doesn't know before it measures it how big that content is going to be. So unspecified is the parent hasn't put a constraint on the child yet. So after Android figures out how large to draw its views, it must determine where to draw them. And it does that with the OnLayout function. Now, these parameters here are for the, so it's Boolean if it's changed, if that element has changed or not, and then the left, top, right, and bottom values relative to the parent object, or the parent view, rather. One of the things that happens during this, during this layout and measure pass and all that stuff is sometimes because of the unspecified values, things have to be measured and laid out over and over again. One thing that might happen sometimes is like if you have a vertical linear layout and you say measure with largest child. Well, it doesn't know what the largest child is in advance, so it goes through one pass to measure everything, and it says, this is the largest child. Okay, measure and lay out everything again. So what that leads to is a process that we call double taxation. And though it says double taxation, a lot of times it can happen a lot more. If you have a really complex layout, you can have exponential layout and measure calls if you have a linear layout inside a linear layout inside a linear layout. And, you know, this might seem like, oh, it's simple, don't do that, but I have seen that with a lot of views, because if you don't know that you're going to pay that penalty, it's like, why, you know, who cares about it? So why is all this important? The reason why this is important is because of this figure up here, 16 milliseconds. We have 16 milliseconds to draw everything that we need to draw in an individual frame in order to keep to 60 frames per second. So that's a short amount of time. But there are some phones out there right now that draw at 90 frames and 120 frames per second. So this could very possibly go down in the next couple years to 8 milliseconds. So if you have something that is having that measure call, you're paying that penalty of measuring things and laying them out over and over again, or if one thing moves, it shifts all these things around, it's going to be hard to hit that 16 milliseconds. So you might be thinking, okay, I'll use relative layout instead of nested linear layouts. Well, good, because that does reduce the hierarchy in your views. But relative layout, often you have to do at least 2 full passes. So it doesn't always save you from things. You might be thinking, okay, I'll use grid layout. Now, grid layout is good in some cases. It does some pre-processing to give you some really good performance. But if you use gravities or weights, your measure pass is going to degrade down to linear layout. So we're going to use constraint layout. So constraint layout is a layout that improves on all of the things, all the pain points from relative layout and grid layouts, and it also includes some new features with other layouts that's come since relative layout first came out. And it allows you to reduce the complexity of your code, both from a developer standpoint, because it makes it easier to read the code, and from a runtime complexity standpoint. It arrived in Android Studio about 2.2, 2.3, and it's been made the default layout since 3.0. It's a support library, so it is not bound to any specific API level. And it is supported way back to Gingerbread. So, question, does anybody in here have an app that is from before Gingerbread? Okay, that was a no for the video. That's good, because if you're still having to support something on API 8, which is like 6 years ago, you got more problems than constraint layout. So, what are constraints? Whether you know it or not, you've been using constraints since you started messing with Android. Because if you have a linear layout, say it's a horizontal linear layout, you're putting a constraint on each of those views that they need to appear at the end of the view that came before it. Yeah. And then when you're putting a weight on a view, that's also a sort of constraint. So you've been doing this already. It's not a specific new thing. It's just that constraint layout has codified how things work and put it all in one package. And it is very similar if you've used iOS to the auto layout stuff, but we'll get more into that later. So the thing that came out was a new layout editor. So in addition to the design view that we all love and used before, we have a blueprint view. So here's the design view that we've used, and here's the blueprint view. And the key difference between the design view and the blueprint view is the design view is how you are going to see it on a phone, And the blueprint view is basically showing you the views that are on screen and the interactions between them. Another thing that we got, and it's zoomed up a little bit, but it's fine. I'll show you more in detail. But this part up here that you can't see, we got a new box of that shows us some information about the specific view. But this is another change on the attributes view, is that it shows us a shortened amount of properties instead of the full list. The full list is still there, but for a text view, the things that you're probably going to adjust are what text it is and what the font size and things like that. So to try and make it easier for you, they've shrunk down the amount of information that's on one screen. So before I get into adding constraints, I'm going to talk about taking out constraints first, just because when you create a first sort of default project in Android Studio as of 3.0, you get a screen like this, where this is a text view, and then there are constraints to the top, the left, the bottom, and the right. So the way that you remove those constraints is you would click either the little circles here to delete a connection. You can delete it in the blueprint view right there. You can also, and it scrolled off, that's fine. So there's also a delete all connections up here that you can't see. I apologize for that. And you can also delete them over here. So when we're adding constraints, likewise, we would click one of these buttons for the left, right, top, or bottom. So let's click this left one and drag it over to this side. And once you drag it over to this side, it's basically saying that I want to constrain this text view to the left side of my UI. And because this is the only constraint that's acting on this view, it's going to move over to this side to indicate that this is the only constraint that is acting on it. Likewise, for the right side, I would click this circle here and drag it to the right. And then when I do that, it's going to reposition it in the middle, because these two constraints are acting on it at the same level. And we can also see that up here we have a little circle here, a little toggle slider that says 50 in it. And basically that's saying that there are that it's acting on the constraints with 50% bias between the two constraints, so that if you drag it from one side to the other, it's going to change how they interact with that specific constraint. Okay. So next we're going to talk about the new attributes view a little bit more. Pardon. So yeah, cool. I can see it. So here is right here. So as I was saying before, the default view is just with a text view in it, and this has my constraints taken off of it. So the most prominent part of this box here is that there are all these greater than symbols. And you can tell from the UI that that corresponds to wrap content. It's kind of, I tend to think of it as kind of like a compression of this is constrained to as big as it's going to be. Do you need me to look over there to be like all posy or something? Okay. Sorry. So yeah, so that's wrap content. So if you click one of these values one time, it's going to change it to what looks like a pipe symbol. And if you've seen designs or whatever, a lot of times in the mocks that I receive from designers, they use the pipe to be that's the set width of the thing. So when I clicked, one of these symbols, it changed the height to 19 dips. And then what's this one? Oh yeah, I already talked about that. And this is the one I was looking for. Oh, this was just saying that in order to show you the next one, I needed to add constraints to the top and bottom. Because when you click it again, it changes that specific dimension to match constraints, which if you use match parent before, it's kind of the same. So it will make it take as much space as the constraining parent layout. So you can do that on with the height or with the width. So a thing about match parent is it's not currently supported in constraint layouts. However, if you're using Android Studio 2.3 and the beta of 3.0, it will allow you to use match parent, but you should consider that a deprecated pattern and move over to Android Studio 3.0. Like, I'm not even sure if Android Studio 2.3 even allows you to do match constraint yet, because it doesn't fully support constraint layout, because as I was saying before, given that it's a support library and it's unbundled from any specific version, they've made a lot of advances. So like when I was starting to do this talk, starting to prepare, they had just released Constraint Layout 1.0, but a couple weeks ago they've released 1.1, which have added some things to my talk that you'll see a little bit later. So I already talked about that. Yes, I talked about all that. Oh, wait, no, I didn't. These show what the margins are. And yeah, they show what the margins are. And that was pretty much the only thing I think I was going to say on the slide. So chains. Chains act like a... they give you kind of linear layout behavior on a single axis. So these are things that you can use to sort of do behavior like that. And I apologize, it's a little bit hard to see, but here's a text box, and here's a text box. And they are chained together. And the way that you make a chain, so I'm going to go a couple slides back. So for any object, if it has, like, say these are two objects. If this object has a constraint, a right constraint going to a second object, and this object has a left constraint going to this object, they are chained together. And there are a couple different chain types that you can cycle through. But in the UI, it will show you a little chain link thing that allows you to cycle through them. And here is the delete all constraints button that I was telling you about like 20 slides ago. So this is what it cycles through. Basically these top two, if you don't have any weights assigned to it. So as you can see, this is a way that you can do a linear layout, either vertical or horizontal, in a very concise way without having to worry about having a linear layout inside of a relative layout because you need it for positioning or something like that. How many designers are in the room? One. Okay, cool. How many Android developers? I'm guessing everybody else. Okay. I'm going to talk about both of you guys, all of you guys, and gals, and people. Let me say it that way. So one of the things that I've noticed being an Android developer that's had to learn design from making a material design course is designers sometimes design things that are hard to represent in the target platform. And I remember earlier on in Android when I was working with a predominantly iOS designer who loved to put badges everywhere. And he's just like, well, why can't you just put a badge on it and tell me how many emails or something I have? And I'm just like, that's not possible in Android. And they didn't understand that. They also sometimes design things that are hard to represent in static drawings. I spelled that wrong. Oh, well. Developers, on the other hand, optimize for terseness, and they will often drop things from designs that they don't understand or seem too complicated. Is that your experience? He nods yes. So basically the next things that I'm going to talk to you about help sort of bridge the designer-developer battle interaction by giving us a common language to talk about some of these things. So we've all dealt with mocks, and there are a couple of different ways to deal with something like this where you have a bunch of elements with individual margins and spacings and stuff like that. Yes, I just said that. Okay, so one thing that you could do is for each of those elements, set all those spacings and margins individually. That's cool, but if one of them has to change, you have to go back and edit all of them, or try to guard against that by using a setting, a styles file or something like that. Another way you could do it is put them in another layout. So a lot of times from beginning developers, I'll see them using linear layouts for positioning things. So there will be 3 or 4 linear layouts in another linear layout or another relative layout, which is bad because of all of the double taxation things we talked about. Third thing that I've seen some people do is use Android widget.view elements as placeholders. Now, this isn't as bad, but one of the problems with this is even though you might set that element to a 0 width and a 0 height, Android doesn't know that you don't intend to draw it. So it's still going to go through for all of these elements and try to measure them and lay them out and position them and stuff like that. So the way that we get over that is with virtual helper objects. And what we have are grid lines, barriers, and groups. So starting with grid lines, we are able to set a line that we can position other objects off of it. Now we can, for this line, that's going weird. Okay, so for this line, we can have it be positioned from the left, the right, or a percentage of the layout view. And we can do that both in the UI and in XML code. We can see our grid line right here. And for this one, I have it with the percentage, with the 5% from the left edge. The next thing are barriers. So this applies a lot in internationalization because different languages represent words differently, of course. But some of them are a bit extreme. So like for German, the word for Congress is double the length of, well, this is a rough translation of Congress, but the word's double the length of the same word in English. So if I were doing a UI and I didn't account for that, I might have a label that would go over or overlap one of my other views. So the way that you do that with barriers is similar to what I showed in here with groups, is you can set a view to use a barrier, and that basically forbids that view from going past that barrier. It will cause it to word wrap and things like that. There. All right, so the next thing are groups, and groups allow you to turn on or off the visibility of a selected set of views all at one time. So this is something that could be very useful if you have a complex UI, and as opposed to making a custom view or have some interesting, weird, dynamic changing of objects around, you could possibly render everything as one view and then just turn on and off what needs to be shown at the appropriate time using transition sets or something like that. And this will kind of like reduce your rendering time because the stuff is already there as opposed to having to regenerate it. So some of the more cool stuff that just dropped in Constraint Layout 1.1 is placeholders. Now, this is a sort of controversial, I would say, view, new helper type, because it's relatively new and the use case hasn't been built up for it. But basically how it works is this. Placeholders are views that you can put in your layouts, and at runtime, you can use this function, set content ID, and you set it to the ID of any other object that either exists in your view, any other view, Android widget that exists in your view or not in your view, and it replaces the placeholder with that value. So I've seen some examples with people using it with like merge to sort of use as a sort of templating thing where they have their UI in their in one XML file and then merge in the views that they're going to use. But it doesn't feel as nice to me yet, so I'm sort of on the fence of whether this will be useful. But it does give you a sort of easy way to do transitions, because if the view already exists in your layout, when you do a placeholder, it moves that view to wherever the placeholder is, and it disappears from the original place. So that's cool. Another one of the weirder things is circular positioning, where you can position a view at a specific radius and angle from another view. I'm not sure why you would do this unless you're making like a clock or something, but it's a thing that you can do, and here's the code to do it, I guess. So to recap, and I have no idea how long I have or if I'm on time or whatever, or speaking really fast, because I speak really fast sometimes. But anyways, to recap, double taxation is really bad. Constraint layout is the default layout for Android Studio moving forward, so you should endeavor to use it as much as possible. And I advise you to also use the cooler things like barriers and grid lines to make your UIs look closer to what the designer's mocks actually look like. Because believe it or not, it does. When you're not randomly dropping things, you both sort of have that contract of, well, this guideline was supposed to be this many pixels away from it, whatever. This needs to change, or this hasn't changed. It makes it a lot easier for you to just do your job. And especially when you have designers that also code Android, there could be a nicer handoff between the two.